Okay, well, excellent. Welcome everyone to this IES webinar, also held as part of our Inheritance of FWR. This webinar is on desert cities, wild green fields, systems of systems approaches for urban water management and rural land use transformation. This webinar has been organised to coincide with the Water Theme Day at COP27 this year as part of a programme of IES activities during COP27. We're delighted today to be joined by Simon Spooner. Simon is an environmental scientist working for Atkins Consultants in the UK. He specialises in developing and applying mathematical models combined with social, political and regulatory methods to plan and design better infrastructure systems and improved environmental conditions. After Simon's presentation, you'll have the opportunity to ask questions, so please do submit these in the Q&A option at the bottom of your screen at any point during the presentation, and I will then read these out on your behalf later on. This webinar is also being recorded and will be made available on the IES YouTube channel. Thanks so much for logging in today, and a massive thank you to you, Simon. I'll hand over to you.
Great, thank you, Ethny. So I was asked to put together a little presentation for the Water Day, and what I'm trying to do is to bring together a few things which I've been working on in both urban water and sort of peri-urban development, how cities stretch out into the country. So just to say a little bit about where I'm coming from on this, which maybe make some of the ideas tie together a bit more. My background is initially in urban drainage modelling, sort of draining, this sort of sewer modelling, drainage modelling, flood modelling, and particularly urban pollution management, which is the sort of overflows from rivers onto from sewers into rivers, and then sort of then grew into some of the early work on sustainable urban drainage and green infrastructure. I spent nearly 15 years or so actually working in China on various projects, initially World Bank, looking at sort of urban development and different ways of undertaking urban environmental development, improving the environment of urban cities, and that included the development of sort of sponge cities concepts, which is taking the ideas from sustainable drainage and putting them into a different context. And then more recently looking at sort of land use transformation and natural flood management, water quality management, all the ways in which you work with farmers, landowners to change how you manage water, and then also how that ties in with the energy nexus and climate change challenges that we have, and water's role in that. And one of the things I'll particularly draw on today is some of the work we've done recently looking at how to develop fully recycling water systems for new cities developed in Saudi Arabia, which is sort of a more comprehensive way of looking at how the water system works. So I'll go over urban water systems, how they integrate also with energy and with natural systems, how this is now looking at that boundary between urban water development and also sort of peri-urban and rural development. And then as you look at how do you plan those sort of peri-urban areas, how do you plan from a livelihoods perspective, sort of looking sort of wider, economic, social, natural capital, but not just infrastructure, but how will people benefit from it? And then the main thrust of this talk really is about how digital tools will facilitate that process, both planning the transition and then ultimately to create operational tools that allow you to work much more complex systems in an effective manner. So I draw from quite a lot of different sources, but so how to bring together the economic, social, natural capitals all in one sort of mediated digital system. So sort of just talking of the evolution of that process, I'm sure many people are familiar with the concepts that our traditional hard grey engineered urban water systems. We're gradually trying to make those greener, bring in natural systems, decentralize a little bit, make things a bit softer. So lots of work has been done on that, and there's all this sustainable urban drainage, SuDS, has been developed over the last few decades, how to put things into cities that bring a bit more of that nature in and improve the behaviour. Not going to do detail on that. Similar ideas across the world. In China, they have the sponge cities concept, and we've been quite involved as Atkins in doing very many sponge city schemes there and in developing some of that regulation. It's basically the same concept, but it goes a bit wider in that there's a lot more about improving water resources and resilience and integration with aquifers and water storage and things. But otherwise, it's a similar sort of concept. But I'm thinking now about how these evolve into the next stages of really looking at that interaction also between the building and the urban area, how those work together, how you can recycle and move water between them, and also the role of energy in that, recovering energy in the water, reusing that within buildings, and also reusing it on a wider scale, which I'll come to in just a sec, but also thinking on the use of those green spaces, the climate impacts of them, heat mitigation, the full interaction with groundwater and other elements. So really sort of trying to bring together systems a bit more. And I mentioned about the water and energy, and I think there's a huge potential in future for a lot more interaction between the water and the energy systems. Water is a major energy carrier, and if we are going to convert a lot of our current urban settings to be net zero, it's no good talking about building a lot of passive houses, because we can build new ones. That's great. Super insulated houses, which are very low energy, great for new stuff, but that does not retrofit to existing buildings. You pretty much have to knock them down and start again. And just popping a few air source heat pumps on the side of a building is also not very satisfactory. They really struggle when it's cold. So you need a stronger source of heating, and I think that heat networks, and in particular, not just like the old high temperature networks, which basically had a great big fossil fuel boiler in one place and spread the heat around, instead having sort of multi-centric networks that can make use of solar thermal energy, waste heat, ground source heaters, store it, and keep that through the seasons. And these can also then become sort of a complex, a network of linked networks, different styles. You can have lower temperature balanced networks. These are the so-called 5th generation networks, which I think is really the way to go in future, where you've got a lot of lower temperature water and each building's using a heat pump to take out, and then they can provide hot water into their building without having to change their building internal systems. Or you can have the older sort of higher temperature ones, or the very high temperature networks, and these can link and pass energy between them using heat pumps. So I think there's a long way in which there's a new utility system that needs to develop. So that's sort of introducing one of the new sort of forward-looking elements. But now I just want to go back and sort of think more first about urban water before I go on to the sort of peri-urban and rural setting. So with urban water, we do need to integrate more with the natural and the energy sort of cycles and nutrients. So the first stage of being able to do that better is to model, and we have been modeling water systems for a very long time. That's what much of my career has been about. But we need to be integrating a little bit more, not just the physical models, but also sort of economic and social modeling into that, and to understand how these systems interact. And that can also then lead on to evolving into having digital twins of the assets. And the difference between a digital twin and a model is that the digital twins link to the individual assets and the owners of those assets, so that the model has an understanding, and there may be multiple assets in that digital twin with different owners and different tags, and it can link that. It also links to live data on the asset's state and can facilitate operation. So traditional engineering models tend to be planning tools, whereas digital twins can become operational tools. They have a role in planning, but can be also much more operational. And they can then allow much more complex interactions between multiple stakeholders within the infrastructure. And especially when you've got overlapping utilities, overlapping sort of infrastructure sectors, the water, the energy, the transport system, the building systems, you need to be really able to track how flows, materials, energy, and financial transactions and contracts are moving between those different elements. So this is the sort of next level of development. So I mentioned about where does this take first in the urban water model, and the stages towards building up a sort of a fully layered understanding of urban water. And as part of I go through this stage of the talk, I'll go through quite a lot of sort of modeling systems which we've developed at Atkins. Just because those are the ones that I know doesn't mean lots of other people have comparable sort of systems. It's not a sales pitch. It's just these are some examples. We have a brief to develop sort of water services for new cities in Saudi Arabia, which will be sort of closed cycle, sort of complete water recycling, building cities where there is no water, basically. So all water coming from desalination. And how do you start to understand how all the different elements of your system fit together, the water resources, the supply, demand centers, and then from the water generated from those, how it goes for treatment, how you recover the flows, the energy, the biosolids, the different minerals and salts and things, and then send that back around the system, either directly or mediating it through green infrastructure, and dealing with all the different elements of that. So this is a very different sort of modeling challenge to the normal sort of hydrodynamic, how does my water flow, or how do my water resources organize, because each layer has to sort of pass off to multiple other layers. In the Saudi setting, this is about complete recycling. In the UK, you may be pumping that water back up to the sort of water resource areas and being able to utilize your resources better. So an example of this, where it's been, I've actually applied this before, is in China. And this is looking at a sort of a region, Qingdao's a city of about 8 million people, and looking at the way in which all the different water resources that come there, including the big Yangtze River transfer schemes, desalination, reservoirs, how those feed into different treatment works, demand centers, then go to wastewater treatment, and that those can then be recycled and reused. And this is just a way of getting that network to fit together, both what we're showing here for the flow, and then this is for the energy that's associated with those flows. And then you can start to look at the network relation, and then how that flows around the system, and understand how your model fits together. So that's some discussions of the sort of harder pipe water supply recycle elements of it. There's also how that interacts with the natural situation in the city, and the sustainable urban drainage elements, cycling back to that. Before I was talking about SuDS as what it is, and now it's how do you model it? How do you get those systems coming in? And we have examples of SuDS Studio, which has multiple GIS layers, where you can analyze catchments, understand what's going on in them, the different surfaces, the potential for different schemes, and then you can help to design those schemes, put them in place, and also understand how they will operate at a greater level. So this is a a sort of a SuDS analysis of Greater London, the whole of London there, and looking at what sort of solutions could be implemented, what their effect would be, and then there's a few more things. That was a bit of a smoother transition than I was expecting, but there we go. Then this sort of shows the effect on the flows from each of the subcatchments, and how that changes, so you can understand what those will do. Unfortunately, wouldn't be effective enough to avoid having to have the tunnel. But as well as sort of working out those water flows impacts, when you start putting this green infrastructure in, you get multiple benefits. So, you know, you're also getting green spaces, which have aesthetic improvements, recreational value, air quality improvements, better biodiversity, all sorts of multiple benefits that can come from that. And then within this system, you can apply value to those benefits as part of a cost benefit analysis. So to sort of summarize on that urban water element, you know, we are moving towards having more of this blue-green infrastructure, but there are limits on what you can do with sort of nature-based solutions and everything blue-green. You do still need quite a lot of hard engineering. You still got to pump all that water around, treat it, recycle it, uses quite a lot of energy. And when it rains, SuDS will help you with a small storm. When it really buckets it down, when you've got a real big storm coming in, you need some big channels, and you do need hard solutions still. But we can look wider at water as a utility, not just as a water utility, but also for energy and for the provision of multiple benefits. So how do those benefits of flood protection, providing nature, improved health, carbon sequestration, temperature management, internally in buildings and of the urban area, how do these interact? So you sort of understand those interactions between buildings, the spaces, and surrounding areas. How do we move that energy, store it interseasonally as well as over periods of days? And how does one recover the energy and the nutrients and use that? And when you look at the energy, you can also a couple of sort of interesting analyses I've had when sort of analysing the energy. Desalinating water is quite high energy to take seawater and turn it into fresh water. And it might seem a total waste to then evaporate that water for cooling. But actually, that is massively more efficient than running sort of dry air conditioners that just run heat pumps. So actually, increasing the amount of desalination energy you use for desalination can reduce the amount of energy that you need to use for cooling, and cooling is becoming more and more important, of course. So you need to look very carefully at your energy cycles in hot situations. Another is that there's actually more energy in the warm temperature of sewage, the energy that's added to it, than there is in all the biogas that you can recover from it. We often think, oh, energy recovery from sewage, oh, we take the biosolids, we get some biogas, and we get the energy out. Just the warm water is far more energy than you'll ever get from your biogas. And linking that into your urban sort of heat recovery systems and reuse can be very, very helpful. It's not going to provide enough to heat the place, but it can make a useful contribution in places. And also, we need to consider that there will probably be a future of plentiful renewable energy resources, you know, such that using electricity isn't immediately incurring greenhouse gas emissions. So, you know, when we're looking at carbon savings, it's not just about energy savings. And if we can make the overall system more effective, then that's very important, even if it does increase energy use. And you need to model that flow of all the energy and the materials through the systems, understand the links, the different layers, and then to develop metrics that can track that in a simplified way. You can end up with so many different variables, and you've got to try and come up with some simplifying metrics and link that to the economy. And that allows you to go into service-based delivery. Those metrics need to really relate to what is the service that this infrastructure is providing, and how well is it providing that service. And that's what you're really valuing. That's why you build it, is to get those services. And this is again where we come back to digital twinning, that the twin can sort of link the ownership of the assets and the contracts and the relationships between the owners, the services that they are providing, and understand the link between that and the operational performance. So it can help you to operate your assets more effectively, and also to sort of link different systems together. So I'm going to move on now to what I was saying earlier about sort of peri-urban development. We have the urban and we also have peri-urban. And I'm using the word peri-urban, not suburban, because in a way, it's how do we move away from suburbs and suburban sprawl. I mean, there are some very nice suburbs out there, but there's also an increasing tendency to basically plant fields of houses, little urban, dense new developments surrounded by green fields, which have just got some barren wheat and grain. It's not really a natural environment at all, and it's not an urban environment, and it can be very dissatisfactory. So, we need to soften that line between urban and rural development. And we have a tradition in the UK of sort of green belts around our cities, to give those lungs to breathe, and very, very strictly controlled development in those areas, protect the farmland. And I think, we've got a huge change happening in the way in which we manage farmland and how we're going to develop in future, which I'll come on to. And that means that maybe we need to change some of these concepts about, bad development of buildings in green areas, or that farmed nature that's good and that's great. Actually, we need to sort of change some of those concepts, and particularly to think more from a livelihoods based mode of development, how to develop sort of places which will lead to good quality of life, where people will not just have a house or have a few utilities, but there is a real potential to make a livelihood there, to have community, to have work, to do more than just some infrastructure. So why is that not moving on? There we go. I don't know why that happened. Yeah. Okay. So I was saying about the transformation of land, and how is farmed land, I think, is changing enormously. We need to, with climate change, big part of the whole climate change equation, and a lot needs to change. So maybe we need much greater intensification of our land use. In some cases, sort of indoor agriculture, greenhousing agriculture, you can get massively greater productivity from a very small area of land. It's high energy use, it's high labor use, it's high capital investment. But if you can do that, you can then release a lot of the land, instead of having this sort of halfway house between intensive and non-intensive. So more of the land can become de-intensified, where you're having much higher quality produce produced. You're focusing on regenerative agriculture, soil focus, putting in permanent crops, and also providing these multiple benefits, ecosystem services, and climatic services and things. And then really needing to integrate society, people, nature, community into that, so that the people who are living in these peri-urban areas are involved in some of this rural life. But it involves a lot of different stakeholders. It's less labor intensive than the intensive stuff. But this can be a different mode of working. What I do have to flag here is some of the sort of harder to deal with stuff. I mean, whilst one can grow vegetables and herbs and quite a few things in greenhouses and indoors, the basic staples of grains are difficult, and it's quite hard to see how to really move all of that much of our land use away from that. And I think that possibly there will be a place for the synthesis of some of those basic staples. I mean, really, sugar is a very simple compound. Why we have to have vast fields of sugar beet and sugar cane to do it, when that can be made from basic chemical components, is questionable. To some extent, the same with carbohydrates. there seems to be very, very little emphasis on food synthesis. There's a lot on meat synthesis and replacing meat, which is incredibly complicated. And yet the really simple stuff, nobody seems to be looking at it. That's just a little flag of mine. But also, how do you transform that sort of lived land environment, the suburbs? How do you sort of embed homes and buildings into rural life, and make use of that land between the buildings, get that community engagement? But if you've got a more a widespread sort of spacing of housings, obviously you've got a transport issue. You are a bit more limited to road transport and cars, but as we move to electric vehicles, the downsides of that become less. And if in time we can have autonomous vehicles, which are not that far off, at least in limited ways, then it can be more sort of feasible to have efficient transportation, even when people are more spread out. But part of that is about people being able to work from home more, different things, and then local hubs for that working. And those sort of local hubs, I think, can integrate with the sort of development of farm sites and different areas, bringing industry, office hubs, trading, that sort of thing into rural areas. And the example here is a sort of a one I did myself. This is actually our own, what was once a small farm, my family owned, which we've converted into sort of industrial units where you can trade, you can have you can have goods delivered there, you can have office work. You can see it's got full solar roofing. It also has sustainable drainage and things. You can develop these sort of businesses, and it's a very good business model as well. This was very much a leading development from a planning point of view, but there is more of that happening, and more could do. So then I want to look at some of the work that we've done on how do you work with farmers, with landowners, to change the way that they're managing their land, to give those ecosystem services, and to link into sort of contracts and structures, and how you make that happen. How do you pay people for doing something? So the example I'm giving here is from natural flood management. I'm drawing this from a project over the last couple of years with the National Highways, where we've run a pilot where we had about £1 million to fund farmers to put in various measures which would reduce flooding on the strategic road network in a few certain places. So we ran a pilot, and recently we've been looking at how we can take that forward. So I'll come back to that, but I'll first sort of remind us some of those elements. This is NFM, natural flood management. This is basically doing something on the land, planting trees, aerating the ground so that it absorbs more water, putting in storage ponds, leaky barriers and things that hold water back, all sorts of different measures. So we've got about 50 different measures that one can come up with, that one can plan and implement. And those then have benefits in terms of reducing the runoff to a river or directly to a floodable or flood risk area. But as well as reducing the flood risk, these same schemes, you plant lots of trees and hedgerows and different things, they also have multiple benefits. And those multiple benefits or sort of other things can also have value that contributes towards the sort of cost benefit of the scheme. So, greatest slide, this one, but basically this is trying to explain how well we have a product, a sort of digital twin model that works out how much flood protection each scheme will provide, and then another one called Natural Capital Studio, where we use natural capital measures to assess the other multiple benefits that such a scheme gives, and this we can then apply a sort of economic value to those. So that's the effect on food production, water supply, biodiversity, recreation, and then also sort of climatic services, air quality, removal of pollutions, improvement of water quality, climate regulation by carbon sequestration and greenhouse gas emissions and things. So you have another of these things, multiple GIS layers, understand the catchment, and then you can calculate for each different scheme that you put in what are those benefits. and that can then allow you to sort of trade those benefits with other stakeholders. So the concept here is, you start from, this one was for national highways, environment agency, big landowners, water companies. They all are interested in this area and undertake schemes that may be flood focused, or they may be focused on water quality. How do you build out from your single little scheme that you're trying to do somewhere? Because if you're trying to change the flood in a whole valley, you've got to do it over lots and lots of areas. It's no good just doing one thing. So you could have one stakeholder leading that development, doing lots of schemes, and bringing other partners in, or you can ultimately go for the multi-stakeholder approach, where you've got lots of people who are doing different things, but are able to understand how they can trade between one another, so that even though one scheme might only have a very small value to one of the other stakeholders, they can realize that and sort of cross-fund things, which can start to make this kind of land use more viable as you start to get some more dependable revenue streams and investment streams related to it. But it'll take a long time to build up. Coming back also to this sort of livelihoods-led development idea. So as you want to go to sort of the wider development of sort of rural areas, peri-urban areas, having this quality of life focus and understanding those multiple benefits, so that you can understand, get some cost benefit analysis for taking forward different ways of doing things which are much more based around developing natural as well as economic capital and using nature-based infrastructure. So a couple of slides just to sum up at the end. What are we doing? This stage, we're enabling multi-stakeholder, multi-benefit land use change, changing the way that we structure the use of the land. I think we need to develop those concepts of natural capital. There's a huge amount of work that goes into natural capital, but it's still got a long way to go. How you really realize that, model that, communicate that, and use it as a quantitative tool. Then we are now at the stage where we can use these nature-based solutions, and they can deliver quantifiable services and benefits. You've got the sort of physical benefits of them, and also the economic benefits, which can be quantified and traded. We can integrate that urban and rural infrastructure development, understanding the importance of the delivery of water, food, energy, as well as residential and commercial services and ecosystem services, so how these things fit together. So bringing together these multiple capitals can account that. Of course, we've got to be very careful. This is still development. These things will keep changing and shifting. They give variable results. It's not right. It's not correct. It's not like a nice hydraulic equation, which is pretty reliable in telling you a water surface. This is going to give you very variable results, but they are still useful, and they can guide that planning, and they can lead to operational systems. So we need to sort of put in the work to develop those tools. I list some of those Atkins ones. As I say, lots of other people will have other tools. I don't know the names of all of them, but they've all got that potential to grow and to exchange and to understand how they come together. But that modeling process is important. And then we can develop these sort of overlapping systems for urban, peri-urban, rural processes. And so finally, sort of talk about how digital twins can enable this kind of multi-benefit change and sort of focus on that sort of quality of life change. So the different elements, these can embed into digital twins to facilitate planning, the bidding and the investment, but also operational. And one has to develop sort of in stages. Sorry. Message there for some reason. Develop in stages, not trying to do too much at once, but gradually getting a bits working, improving the integration, interoperability, linking things up, but also trying to keep things as simple as you can as you go. But once you have sort of digital twin, you understand these different services, you can start to embed service-based contracts into that digital twin system, so that the vital thing is that there is revenue available for the people who are participating. They've got to make a living from this. I mean, a farmer's not going to stop growing wheat and start doing multiple benefit if he can't see a consistent sort of revenue and livelihood from it. So that is a very important element. So we can sort of go from just having some data to having models to having these digital twinning systems that can sort of manage some of those complexities, bring different systems together, and manage those. So that's really sort of some of the vision for that. And one can go on for a long time about the details of how one brings that together and examples of the different elements of it. But for now, I'd like to open up to questions on that. Thank you.
Thank you so much, Simon, for that. That was such an interesting presentation, and really aligned with the IES view of the importance of systems thinking for approaching some of these big issues facing our environment and society. So yeah, please do, any of our attendees watching, please put in so your questions in the Q&A function at the bottom of your screen. We've got time for a couple of those now. So just to kick us off, I was really interested to hear about the kind of multi-stakeholder catchment partnerships that you were talking about, and kind of thinking about how you can see the multiple benefits of a particular project in other areas. How have you found the kind of, how has it been making a business case with that for different people that you've worked with? Has there been a lot of receptiveness to people looking at multiple benefits, especially if they're more expensive than doing a scheme that's kind of just looking at one area?
Yeah, that is a difficult area. If I take the example of the National Highways program, which we ran, the interest in the multiple benefits and the quantified value of that is there because they do have responsibility to demonstrate that they are providing these services. You know, they have to show they've got a plan to take the nation's highways net zero, obviously not counting the things that are coming out of people's exhausts, but at least as the infrastructure. So if they can show that there are things which they are doing that are contributing towards that, then that is a worthwhile for them. The flood risk case. So from the farmer's point of view, that's an off-site benefit, but for the highways agency, it does demonstrate that for a reduction of however many 100 cubic meters in runoff, to do that by natural flood management on some of the schemes which we did, worked out about half the cost of the standard value of putting in storage actually on the little bit of land, or putting in new drainage, or the typical cost of reducing flood impact on National Highways' own assets. So, these values really are there and can be quantified.
Excellent, thank you. And we've got a couple of questions and comments coming in about the concept of a digital twin. In particular, people asking that it would be great to hear about more examples of digital twin systems, perhaps in a future webinar. But I was wondering if you could just go over quickly again exactly what that concept is and how it works. And perhaps you mentioned it kind of is useful because it brings in both physical data and kind of economic and social data. In terms of the economic and social, what kinds of data do you get coming into the digital twin?
Okay, I'll start off with what is the digital twin, which does start with what is a model. A model is just where you use some scientific and engineering equations to represent something that's physical. The advantage is you can then explore different circumstances. What if I make my building twice as high? Will this beam break? What if I connect two rivers together, or pump water from one place to another? You can model things. They're generally used for planning and design, and are very helpful. That's what engineers spend a lot of time doing in one form or another, be they an equation on a bit of paper or a massive AI-enabled computer vast system. The difference with a digital twin is that you're seeking to replicate that physical asset with a conceptual mathematical model, which, okay, that's one of the stages in modeling. The difference is you're then going to use that as an operational tool. And there is a particular feature of a digital twin is that each asset within the model, the physical asset and the data asset, there's a linking tag. Everything has a unique identifier. This can go off into the whole Internet of Things type of stuff, but you have a link. You have information about that asset, the state of it. If it's got sensors on it, you can have information coming back in. So you've now got a model that is sort of live and connected to those real assets. And you can then use that on an operational basis to react to information that's coming in. You can have either sort of information presented to an operator who makes decisions, or you can have decision systems sort of which may be augmented by algorithms or so-called AI. But it makes the whole thing more interactive. The element of how you link that to the social and economic and financial elements is that when you've got a large and complex set of assets that are interacting, they may be owned by different people. Each element of it is providing a service which is used by other parts of this system of systems. They're going to have financial transactions between them for supply of electricity, receipt of whatever goods or services and things there are. Those contracts can start to be embedded into the digital twin so that the information on the state of those different assets allows you to update the contractual and financial relationships between them. Your smart meter is such an example. Now that is in your house. You're part of a digital twin somewhere in a power company's thing that knows what's going on, and you've got a contractual relationship based upon that asset that's embedded in your house. So that's sort of how that links together.
Amazing. Thanks, Simon. That makes sense. That's really useful. We'll just squeeze one more in, if you don't mind, before we log off today. But do you ever need to consider existing building foundations when designing SuDS schemes? For example, do you have any complex examples of them being on limestone?
Well, I think SuDS, the actual design of SuDS obviously is very, very local to whatever that building is. The example I was giving of our SuDS Studio analysis system, which is there to decide, or not decide, but to suggest what sort of measures might be appropriate. That includes various geographical layers for the topography, the digital terrain, but also the geology and the soil types. Because, if you've got a heavy clay soil, there's no point in having everything running out and expecting it to soak away and putting a permeable surface. Likewise, you've got to be careful with some limestone systems, which can be very variable in their ability to soak away. They can be, nice oolitic limestone, it soaks in nicely and spreads out, or chalk, but some caustic things can be totally impermeable, and then like a sort of sinkhole, and it all rushes away, and you're not quite sure where it's going to show up again. So these are elements which you include within it, but the details come down. At the end of the day, you're going to have to go out there, start prodding the ground and digging some holes, and tutting, and I have a tricky one here.
Okay, great. Thank you, Simon. And actually, I hope you don't mind, can you stay for one more minute just for one other question?
I'm fine.
Great. So what are the timescales on some of the designs that you mentioned? For example, the sponge cities in China and the multi-centric heating systems. Are these in reality today?
They are. Sponge cities that's been running since 2014, and in typical Chinese style, they have spent billions and billions on it and built it out into lots of places. It is a part of their standard urban planning, and as Atkins, we do a lot of urban planning in China, or used to. So that's definitely happened over the last 10 years or so. For the heat networks, this is newer. Obviously, district heating, steam running around. You've all seen old 1920s films of New York with steam coming out of the ground. That's been around for a long time. Scandinavia is half heated that way. Lots of China is heated that way. That's high temperature district heating. The lower temperature 5th generation networks where you're using heat pumps rather than heat exchangers, so you can have everything at lower temperature, but it's much, much more efficient. You don't have these horrendous heat losses of trying to have this hot water stuff going or steam going around. That is in place. So there are networks being put in Plymouth at the moment. They've started work on that in the centre of Plymouth, linking up, I think it's House of Fraser and several other high street buildings there. There's a balanced network at South Bank University as a trial pilot. There's quite a lot of such schemes in Scandinavia. I know in Helsinki they have one that takes water from the harbour and uses that for heating. And there are a lot more. There are quite a lot in construction now. So that is definitely moving forward, and I think has huge potential in the future. To me, this is actually the main solution to the biggest cause of emissions in the UK, which is building. It's those boilers that we all have in our airing cupboards and under the stairs or wherever they are, and we need to replace them, and it's not easy. We can't just insulate our houses. I mean, I thought, oh, I'll insulate my house. I live in a 100-year-old house, which I rent. Go to do that, and the landlord comes back saying, no, you can't do that because it's going to cause all sorts of damp problems, and the house will fall down if you start injecting cavity wall in. It's a lot more difficult than a glib thing to change to make houses super efficient. Whereas if you can get enough heat in by a zero carbon means, replace your boiler with a heat pump, and that's got a source of heat to supply it, then you go net zero straight away. Your house is now zero emissions. You haven't had to rip up your floors and your radiators. You have had to put some pipes down the road though, and share heat with your neighbors. So there's a lot of planning. There's a lot needs to go into it, but in some ways that can be an easier route forward than attempting to have hydrogen boilers or any nonsense like that.
Oh, thank you so much, Simon. That's been so interesting and informative, and I hope all of our attendees enjoyed it as well. So thanks so much for coming to present today. Our next webinar is tomorrow, and we'll be focused on Energy Day at COP27. And for this webinar, we are delighted to be joined by Simon again, but talking about a very different topic. So it actually connected what we were, talking about net zero, and this will be on combustion transition, a simple framework for accelerating our transition to net zero. So please do register for this on the IES website. And you can find other COP27 related articles and events also on our website. So please take a look. Thanks so much for coming today, and I hope you'll have a great rest of your day. Thank you very much.
Thank you.